All right, let's recall some concepts of real numbers. Let's look at concepts of real numbers that we've seen in the past here. So let me go ahead and give you some basic concepts of intro to real numbers. Now, these are basically numbers that we've been working with all along up to this point in mathematics. All right. Now, but let me define real numbers a little differently from your text, perhaps. Let me define it in terms of decimals here. All right. Let's go and define real numbers in terms of decimals here. All right. But before we do that, then let's look at the three types of decimals we have here in the three types of decimal numbers. Let's look at three types of decimals. All right, three types of decimals that we have in mathematics. All right, the first type is what I call the terminating decimal. Let's look at what's called the terminating decimal. Terminating decimal. Now, a terminating decimal is basically a decimal that comes to an end. Let me give you an example of that. A terminating decimal is, for example, 0.5, right? Or if you think of it as a fraction, what? 1/2, right? So that's it. So it comes to it. It ends in the tens place, right? How about one that ends in hundreds place? 0.75, right? Again, thinking in terms of the rational numbers or fractions here that we've seen in the past. How about 3/4 for that, right? But again, focus on the decimals here, right? My point here is that a terminating decimal is a decimal that comes to an end, bottom line, all right? So let's look at the next type then. How about, well then, what about decimals that don't come to an end? How about, well, there are two types of that. The first type will be the repeating decimal. Let's look at the repeating decimal. All right, and this one goes on forever, but it has a pattern to it. So, for example, here's what are some famous repeating decimals we've seen in the past. Well, how about 0.6666 repeating, right? Or you can write that as 0.6 with what? With the bar over the 6, right? Or, most of you probably know that the fraction equivalent of that is going to be what? 2/3, right? So the fraction 2/3 is basically this repeating decimal. So it goes on forever, right? Or how about a little bit of a different pattern here, right? For example, how about let's say 36, and so on. So the 3 and the 6 is basically repeating here, if you will, right? So, oops, excuse me, hang on just a second. All right. So now, thinking in terms of the so let me first of all write that in terms of decimal here. 0.36 with the line over both the 3 and the 6 this time, right? So in this case, the fraction I was thinking of, I was working on the calculator, sorry about that, guys, is going to be 4/11, right? You punch in 4/11, 4 divided by 11 on your calculator, you get this repeating decimal here. It goes on forever, but the digits obviously has a pattern to it. Okay, and so there are many repeating decimals, as you can see, right? Just like there are many terminating decimals. But what about decimals that that go on forever but do not repeat? So let's look at what's called a I'll call this non-terminating. So non-terminating, oops, sorry about that, and non-repeating decimals. So it does not come to an end, so non-terminating, and also non-repeating. There's no specific pattern to it. So non-repeating decimals. Oops, my sketch pad is acting up a little bit. Sorry about that. Decimals. All right. So non-terminating, non-repeating decimals. What are some examples of that? Well, a famous one that you may already know is the number pi. All right. This number is non-repeating and also non-terminating. It's a decimal that goes on forever, and it doesn't repeat, right? So just roughly on the calculator here, if I punch in the number pi, right? So the number we know, pi, if I punch on the calculator, it gives me this long decimal number here of 3.14159 159, 2654, 2654. Actually, it goes on forever. My calculator didn't have enough space to show all the digits. But again, there's no pattern to it. It goes on forever, so it's non-terminating and also non-repeating. All right. Now, another famous number we'll learn later on in this class will be the number e. Let me go and clear off the screen and show you another example of that. So here's another example of a non-repeating, non-terminating decimal, the number e. Now, this is not a variable. This is a number, a real number in the mathematics. So let's look at what that number is here. So let me see if I can find that on the calculator here. E. All right. So E is a 2.71828, and so on. All right. So again, this number goes on forever, and there's no particular pattern to it. This has many applications in science, which we'll learn later on, perhaps. All right. A simpler one, perhaps, is how about the square root of 2? So let's take a look at the square root of 2 here. Okay. On the calculator, it's a 1.14. Oops, sorry about that. 1.41, I should say, 4213, and so on. Okay, I'll be writing all the digits. But my point again is what? That these are decimals that go on forever, and they don't repeat. There's no pattern to it. All right. So again, real numbers can be broken down to, in terms of decimals, into 3 types of decimals. Right. Terminating decimals, such as 1/2. Right. All right. So look at real numbers. Examples of real numbers, such as the 1/2 we saw earlier, or repeating decimals, such as the 0.6, right? That's going to be 2/3, right? In terms of a fraction, all right? Or non-repeating, non-terminating, such as the number pi, all right? So again, so real numbers consist of these 3 types of decimals here, right? Now integers, I consider that as decimal as well, because integers, for any integer you give me, I can write it as a decimal, for example, right? Okay, so fractions consist of real numbers. So let me say that real numbers consist of what? Integers, fractions, certainly, as you saw already. All right, and fractions are called rational numbers, by the way, rational numbers. All right, and pi, that's called an irrational number. So decimals that go on forever and don't repeat are called irrational numbers. Oops, irrational numbers. All right. So we have basically rational numbers and irrational numbers consist of the real number system that we have in mathematics. Right. Now, but our focus here is going to be on how to graph sets of real numbers. Right. So, for example, let's recall that if I were to ask you to graph something like x greater than or equal to, let's say, 5, for example, right? That means what? How do I represent all real numbers on the number line that are bigger than or equal to 5? Yeah, well, we did that already in the previous math class, right? Basically, the idea is then you simply include the 5 here, right? And we have the equal sign here, so we are going to include it. And so to include it means we're going to use a bracket. Bracket goes on 5 and arrow what? To the right, because everything to the right of 5 is bigger than 5. All right? So let's recall how to graph sets of real numbers this way. All right, let's try another one. Let's take a look at graphing. Let's graph x less than -2. Well, again, this time we're not including the -2. So therefore, then we're going to use what at -2? We're going to use what? Parentheses. Parentheses on -2, since we're not including it. And then since it's less than, that means everything to the left of -2 is less than -2. Okay, so let's recall these basic graphs we've seen in the past here, right? Now, with these sets of real numbers, though, we can there are 2 ways to express these sets. All right, let's look at 2 types of notation, set notation here. So let me go and clear this out. Let's look at 2 types of set notation that we can use in mathematics to express sets of real numbers. 2 types of set notation that we can use in mathematics to express sets of real numbers here. So set notation here. Sorry about that. Sketchpad is a little bit difficult to work with here, but so I apologize. But bear with me here. All right. The first type, I'll call that the set builder notation. Is what your textbook uses. So set builder. So set builder notation. Okay. So the Sketchpad will cooperate a little bit here. Second type will be the interval notation. So let's look at interval notation. Okay, there's interval notation. Sorry about that, guys. There it is, interval notation. All right, Sketchpad, come on now, work with me. All right. Anyways, so two types of set notation here: set builder notation, interval notation here. Okay. So what are these types of notations? Well, earlier, remember we graphed x greater than or equal to 5, right? So where we put a bracket, right? Earlier, if I clear the screen out, bracket on 5, arrow, because we're including it. Arrow goes to the right there. Okay. Well, how do we write this in set builder? Well, that's not too bad. Here's how you do this. You start off with the left brace, okay, and then you put an X there. Okay, and then you put a vertical bar after that. Oops, it's just a straight line, guys. Sorry about that. I'm having trouble with the Sketchpad here. Just a vertical line, vertical bar here. All right, doesn't have to be this thick. So again, apologize for the Sketchpad mistake. And then you put the inequality into that. So after that, so x greater than or equal to 5, and then you close off the set with the right brace. Okay, so this is set builder notation. So set builder notation. Okay, sorry about that. So set builder notation for the set of all real numbers bigger than or equal to 5. Now, how do we read this notation? Well, again, we read this as x, all real numbers x. So read this first x, we read it as all real numbers. All real numbers, and this little vertical bar means such that. All right, such that. So we read this as all real numbers x such that x is greater than or equal to 5. Close it off with the right brace. Okay, so this vertical bar means such that. Okay, so just like we had earlier, we also had what? X less than -2. All right. So again, how do we write that in set builder notation? So again, let's write it in set builder notation here. Set builder notation. Then start off with the left brace again. All real numbers x such that, okay, vertical bar such that. So this again, this vertical bar means such that. Okay, x is what? Less than -2. And then close it off with the right brace. Okay, so that's all set builder notation is, right? Just use this vertical bar for such that, and then you just put the inequality into the set here, in between the braces here. All right. So again, all real numbers x such that x is less than -2 for set builder. Now let's talk about interval notation. Right? Interval notation is really sort of based on the graphing of that set. So go back to this first one here, x greater than or equal to 5. Let's look at interval notation on that. Interval notation. All right, interval notation. So we're including the 5, right? So you're simply going to put a bracket on 5, all right? So bracket on the 5, right? Just like the graph, all right? So, and then put a comma. Now it goes from 5 where? 5 all the way out. All the way out to where? All the way out to infinity, right? Infinity. So how do we write that? Well, here's the infinity symbol in mathematics, all the way to positive infinity. So you put, it's sort of a horizontal looking 8. So here's what I mean by that. So the number 8 written horizontally, right? So this means infinity. This little symbol here means infinity. It goes on forever. That means, right? So 5, 6, 7, 8, 9, 10, forever, and so on, right? So infinity. And now with infinity, since infinity is just a mathematical concept, it's not really a number, right? So all this saying that is what the numbers keeps getting bigger and bigger, goes on forever. So it's not really a number here. It's just a mathematical concept. So with infinity, you never use brackets. You always use parentheses next to infinity. So it's going to be parentheses. Right? So interval notation for x greater than or equal to 5, it'll be what? Bracket on 5, comma, all the way out to what? Infinity. All right? Down here, x less than negative 2. Well, again, if I were to graph this here, it'd be what? Here's a quick graph of that. Here's negative 2. Again, we mentioned what? Parentheses on it since we're not including it. And everything to the left of it is less than it, right? So basically, we're going from negative 2 to this time going in that direction. That's not positive infinity. This is what? Negative infinity. So the way to write this then, I need to write it in the proper order though. So don't write negative 2 first. We need to write negative infinity first. Everything out here is what? Negative infinity. So for interval notation for this set, it'll be what? It'll be, again, parentheses, right? Negative infinity. Again, the infinity symbol is what? A horizontal looking number 8, right? This little symbol means negative infinity. So that means negative, if I can fit that in there, negative infinity. Alright, so that means negative infinity. Sorry, the sketch pad is acting up a little bit. But again, this little symbol here means negative sign and then the infinity symbol. So negative infinity. So negative infinity up to what? Up to negative 2. So comma, negative 2. Now this time we're not including it, right? Strictly less than. So it's going to be what? Not bracket, but what? Parentheses. Alright, so interval notation, set builder notation. Alright, let's go and try another one. Let me go and give you this problem here. Let me go and play out the screen. Let's go ahead and write the graph. Let me give you this graph right here first of all. Let's say here is negative 3, here is positive 1, and let's go ahead and put a parentheses on 3, so we're not including it. Let's put a bracket on 1, so we are including it, and we want everything in between. So all real numbers between negative 3 and 1. Alright, so let's write this. Let's express this graph in both set builder. Alright, let's write it in set builder and interval notation. So interval notation. So set builder and interval notation on this graph. Alright, so let's start with the set builder one. So I need to find out how to write this inequality here because what? I want all numbers between what? Negative 3 and 1. So my x has to be in here, right? So how do we express that? Well, here's how we express that. If x is in here, that means what? It's bigger than negative 3. If x is in here, it's what? Less than positive 1. So here's how we write that. Negative 3 is less than x, or x is bigger than, right? Negative 3. But x must also be less than or equal to, since we could be equal to 1, right? Positive 1. So this is called a double inequality. So there's two inequalities here, right? This is called a double inequality. So when you have numbers, when you have real numbers between two endpoints here, or two numbers here, then you have what's called a double inequality. All right. So so for set builder, then how do we write that? Well, so for set builder notation, we simply put that double inequality in there. Alright, so start off with the left brace, alright, all real numbers x, vertical bar means what? Such that, right, such that negative 3 is less than x, which is less than or equal to positive 1. Alright, so that's how we write that in terms of the set builder. Now, what about interval notation? Well, again, interval notation is very similar to the graph. The graph has a parentheses on negative 3, so we're going to have a parentheses on negative 3. The graph has a bracket on 1, we're going to have a bracket on 1. So negative 3 comma 1, including 1, bracket. Right? So this is the interval notation for that. For that set, interval notation. Alright, so hopefully we are starting to get the gist of these two set notations, set builder and interval notation. Let's try another one. Let's take a look at the graph of this here. Alright, let's say here is let's say here's pi, and let's put a parentheses on pi. So parentheses means we're not including pi, right? Arrow to the right. So everything bigger than pi, any number is bigger than pi. So let's write it in both notations again. Right? Let's look at set builder again. So set builder notation. Okay, set builder notation, that's a T right there, sorry about that. Set builder notation is going to be what? All real numbers x, such that what? Well, greater than, right? Everything to the right of pi is bigger than pi, so x greater than pi. All right, can we see that? And what about interval notation? Interval notation, again, we're going from what? Pi, not including pi, out to infinity. So parentheses pi, comma, positive infinity. Again, always have a parentheses next to infinity because it's not really a number. It's just the mathematical concept of numbers getting bigger and bigger. All right, onto the positive side. All right, so interval notation here. All right. Now let's take a look at then joining two sets together here, right? So for example, let's say I give you a problem like this here. Let me go and clear out the screen. Let's say consider this graph real fast. All right. Let's say here is -3, here is +1 that we had earlier, right? This time I'm going to put a parentheses at 3, but arrow goes to the left of it, and I'm going to put a bracket on 1, but arrow goes to the right of it, right? How do I write this in the two notations, right? Again, let's write in set builder and interval again. So set builder and interval notation. All right, how do I write these two? How do I express these real numbers in terms of set builder and interval? Again, this graph is telling me what we want the real number. We want to include the real numbers that are less than -3. We want to include the real numbers that are 1 or bigger. All right. So how do we go about doing that? Well, let's look at set builder then. I need to write these two inequalities separately. All right, because there's nothing in common here. Can we see that? So let's look at the left one here, right? This is what x should be in here, right? X should be less than -3. So from up here you get x less than -3. Can we see that for this part of it? For the right part of it, we want to be bigger than or equal to what? We're including 1, right? So it has to be equal sign. So this will be x is in here. So this will be x greater than or equal to what? 1. Can we see that? Now I need to. So either my real numbers are in here or in here. So obviously they can't be in both places, right? Either you're here or you're here. So how do we join these two sets together, right? Let's look at the word or. Okay, so that means what? That means either we're less than -3 or we're bigger than or equal to 1, but not both, right? So the word or means what? You're joining these two sets together. When you put two sets together, you're also taking what's called the union of two sets. All right, so let's look at the concept of union. All right, union means what? It means joining two sets into a bigger set. So joining two sets into a bigger set, into a potentially bigger set. All right, so we're joining the left set with the right set here of real numbers into this bigger set to include the whole thing, right? Again, except what's in the middle here. So we use the word or to join these two. Now, how do we write that in set builder then? We just put that into the set builder notation here, if you will. Oops. Circle that, all right? So, so for set builder, okay, it's going to be all real numbers x. Okay, so start with the left brace again. So left brace, all real numbers x, such that either x is less than -3 or x is what? Keyword to use the word or here to join the two together. X is greater than or equal to 1. And close it off with the right brace. Okay, so that's set builder notation. What about interval notation? Well, again, it's based on the graph, right? So what is the graph of what is the interval notation for that guy? Well, for the left side of it, it's going to be what? -infinity up to what? -3. Parentheses, right? Not including it. What about for the right side here? Well, right side is going to be what? From 1, including 1, out to what? Infinity. All right? Can we see that? So for interval notation, then, we're going to have to include these two things, but piece them together. That means what? Join them together means what? We need to take the union of these two sets. Here's how we do that. So it's going to be -infinity up to -3. All right? Union, draw a little U right here for union. And this little symbol means union here. All right, union with what? 1 to infinity. All right, so that's the interval notation for this graph here. Right, so pretty tricky, as you can see. Let's go and try another one. All right, let's take a look at something like this here. What about the graph of the following graph? Let's make this 0 here. Let's make this E here. Remember, E was what, 2.7 something earlier we had, right? So I'm going to put a bracket on 0, arrow to the left, and then put a parentheses on E, arrow to the right. Okay, so let's write that in these two notations again. Let's look at set builder on that. All right, set builder says what? Either we're less than or equal to 0, or we're bigger than E. Right, so that means what? That means we want to be, so this part of it is going to be what? X less than or equal to 0. Oops, that's a 0 there. Sorry about that. 0. This part here is going to be what? X greater than what? The number E. All right. Again, E is not a variable; it's a number, right? It's roughly 2.7 something on the calculator. All right. Anyways, we'll get back to number E later on in the semester. But set builder then is going to be what? It's going to be the set of all real numbers X. So left brace X, such that vertical bar, right? X less than or equal to 0. Or, keyword being or here, right? Because you're joining the union of these, right? So you need the word or. X greater than what? E. All right. So hopefully not too bad. Let's look at the interval notation for that. Interval notation is going to be what? From negative infinity up to what? Up to number 0. Up to 0, including 0, bracket, right? Gotta have a bracket there. Again, union, U for union, right? You're joining it with this set here. So this time you're not including E, so parentheses E to infinity. Okay, so this is the interval notation for this graph, right? So again, be able to work with both of these set notations here, right? In terms of union here, joining two sets into a bigger set, and working with these two notations. Now, let's talk about the intersection of two sets, though, because consider this problem. I'm going to clear this out. Let me give you this problem right here. Let's go ahead and look at the set of all real numbers. Well, actually, let me not do that. Let me write this way. Let's look at x. Let's make it x greater than, let's say, greater than negative 2. Use the word and. All right. This time, change the word from or to and. All right. X less than. Let's make it less than 5, for example. All right. So and means what? We have to be both. We have to satisfy both. We have to be bigger than negative 2, and at the same time be less than 5. Well, you may have already figured out some numbers already for this, right? For example, 0, right? 0 is certainly bigger than negative 2 on the number line. 0 is less than 5 on the number line, right? Basically, the word and, again, and means what? Intersection, all right? So union means, think or for union, think intersection for and, all right? Because you have to satisfy both. Or means what? Just one, satisfy one or the other. And means we have to meet both criteria here, all right? So intersection here, right? So how do we write that? Well, this is basically saying what? All real numbers what? That are bigger than negative 2 and less than 5 are all real numbers between negative 2 and 5. For example, if you were to graph these separately here, let me go and graph this separately. But let me put them one on top of the other, if you will, right? And let me include these endpoints. Let's say here's negative 2, here's 5, right? Same thing down here. Here's negative 2, and here's 5, right? Let's graph this first one. So what? Let's put a parentheses on negative 2. Arrow goes what? To the right. So I'm graphing the first inequality up here. Let's graph this inequality down here. What goes on 5 again? Parentheses, but this time arrow goes what? To the left. All right, to the left. So as you can see, these two graphs have an overlap in between negative 2 and 5. So therefore any real numbers that fall in here will satisfy this inequality, satisfy both of these guys, right? So that's why you can rewrite. So basically, again, this is saying what? All real numbers between between negative 2 and 5. That's what this is basically saying. Or to write this as a double inequality, it'll be what? It'll be negative 2 less than x less than 5. That means what? X is bigger than the negative 2, which it is. X is less than the 5, which it is. Alright? Now, how do we write that in set builder notation then? Well, again, we simply put that double inequality into the set builder. Alright, so it's going to be, let's see here, set of all real numbers x such that negative 2 less than x less than 5. Alright, no big deal. Right? What about interval notation? Interval notation, though, is going to be what? Again, based on the graph. Now, let me clean this graph up a little bit. So this graph says what? Everything in between negative 2 and 5, right? So if I were to combine these two separate graphs together into one graph, it'd be just that. It'd be, here's negative 2, here's 5, and parentheses, parentheses, everything in between. All right, does that make sense? Can we see that? So that'll just be what? Parentheses negative 2, comma what? 5, parentheses. All right? So as you can see, that's not too bad if you're joining the two sets together into one set in the middle, what they have in common. So intersection means what? What the two sets have in common. Or means put the two sets into a bigger set. All right? So again, let's go ahead and review those concepts again. So union means what? Combining two sets into bigger set. All right, and intersection means what do the two sets have in common, right? Think and, right? So you have to satisfy both criteria. Find. Let me just say for intersection, find the area in common between two sets. All right. So again, union means what? You're joining two sets into a bigger set. Intersection means what? You're looking for the common area between the two sets. In this case, negative 2 and 5. For this example here, right? Let's go ahead and try another one. Let me go ahead and give you this problem here. Okay, we're almost done, so bear with me here. Pretty long section here, but let's suppose set A consists of the following numbers here. Let's look at set A being something like, let's see here, 10, 11, 12, and 13. All right. Let's make set B consist of the following numbers here. Let's make set B. Let's see here, negative 15, negative 10, 0, 5, 10, and 12. And let's throw one more in, 15. Alright, so set A consists of these four numbers. Set B consists of these numbers inside. Alright, so let's go ahead and calculate the union and the intersection of these two sets. So I want you to find A union B, right? Join these two sets into a bigger set. So my answer should be a bigger set now, right? And also the intersection of these two sets, A and B. A and B. All right, what's in both of these sets? What do these two sets have in common? All right, so let's look at that. Now, well, again, union means what? We simply have to just combine them, right? If I combine these two sets, it's going to include all these numbers, basically, right? So it'll include 10, and you don't have to list the numbers in numerical order, right? So it'll have 10 in it, it'll have 11 in it, 12 in it, 13 in it, right? Everything from the first set, and everything in the second set. Negative 15 is going to be in it, negative 10 is going to be in it, all right? And again, union means what? We're joining two sets into a bigger set. So negative 10 is going to be in it as well. Again, first negative 15, 0 is going to be in it, all right? 5 is going to be in it. 10 is good, but I already had 10 here, right? So I'm not going to repeat it, right? So don't repeat the element, right? And what else then? 12. Oh, again, I already have I had 12 earlier here, right? So I'm not going to repeat the 12 as well. So I'm not going to repeat 10 and 12, right? Because it's already in here, right? And just include the 15 as well then. But as you might suspect then, the intersection is going to be what? 10 and 12. Can we see that? So in other words, the intersection between these two sets, what do they have in common? Just 10 and 12. Alright, does that make sense? Can we see that? So, that's how we find the union and intersection between these two sets. Let's go and try another one. Let's make set A the set of all numbers. Let's make set A such as, let's try this here. Let's try set of all real numbers x such that x, let's make it x, this little symbol here is the epsilon symbol in mathematics, epsilon. But basically you read this as the word is. Okay? Let's say x is, let's make it an even integer. So set A consists of all the even integers, if you will, right? Alright? Let's look at set B. Well, as you may suspect, I'm going to make set B all the odd integers. So x is odd. So again, this little epsilon symbol means what? Is in mathematics. So is an odd integer. Alright? So let's go ahead and calculate the union and intersection, alright, of these two sets. So let's go and find, again, A union B and A intersect with B. Right? Well, again, A union B means what? We're joining the even integers with the odd integers. Well, if I join all the evens and the odds together, what do I get? Well, wouldn't I get all the integers, basically, right? So, in other words, the union of these two sets was basically going to be the integers, right? So, x such that x is an integer. So, I ran out of space there, so let me just abbreviate. INT means what? Integer. All the integers, right? Because that will include the evens and the odds, right, if I were to join them together, right? And what about the intersection between these two sets? Well, if you're even, you can't be odd. If you're odd, you can't be even, right? So in other words, intersection means what they have in common. Well, these two sets have nothing in common. Can we see that? Because you can't be both even and odd at the same time. So therefore, they have nothing in common, so therefore there's no solution, or we say that for intersection of these two sets, this is what's called the 0 with a slash over. This is called the empty set. Empty set. Alright, so 0 with a slash means empty set, means what? There's no solution because these two sets have nothing in common here. Alright, so the union is going to be basically all the integers, but the intersection is going to be what? Nothing. Right, empty set. Okay, so get a feel for concepts of union means you're joining two sets into a bigger set. Intersection means finding out what they have in common. In this case, they have nothing in common here. So sorry for this extra mark right here, so I should just take it out. But anyways, yeah, so practice with the concepts of union and intersection here. All right, as well as the two notations we talked about, set builder and interval notation. All right, let's go and wrap things up by giving you some problems to post into Blackboard here. All right, so let's go ahead and go and clear out the screen. Let's take a look at the post the following answers into Blackboard. So number one, let's go and let me give you a graph and ask you to write in interval notation. Let's write this graph in interval notation. Write in interval notation. Oops. All right, here's the graph. All right, let's say we have something here at -5 and something out here 11. So -5 and 11 here are the endpoints, and I want everything in between. So I'm going to put a parentheses here, so we're not including the -5. I'm going to put a bracket here, so we are including the 11, and I want everything in between. So what is the interval notation for this graph here? All right. How about this one? Let's look at set builder notation. Let's write this in set builder notation. Oops, sorry about that. Write in set builder. All right, set builder notation. Here's the graph of that. Here's the number line. Again, let's say here is 2, and here is 7. That's a 7 there. Sorry about that. All right, and I'm going to put a parentheses on 2, parentheses on 2, arrow to the left, everything less than 2, and parentheses on 7, everything greater than 7. So not including the 2, not including either of these guys. All right, parentheses, arrow to the left here, arrow to the right here. Write that in set builder notation. So you're going to have to figure out how to join these two sets together into a union with the word what? OR. Use the word OR for this to put it in set builder notation. Right? And last but not least here, let's say set A consists of the following digits, 1, 3, 5, and 7. And let's say set B consists of the following numbers, 1, 2, 3, 4, 5, and 6. And obviously, as you may suspect, I want you to find the union and the intersection between these two sets. So find A union B, and also find A intersection with B. Alright, so find out what they have in common. Find out, if I join them into a bigger set, what kind of numbers will be included in it. Alright, so hopefully you can practice some more of these concepts and post it into Blackboard, and we'll go over it in class. Alright, until next time.